Alright guys, here we go, chain rule. I think you guys are going to like this. If you're new to the channel, consider subscribing, and hopefully you like this introduction on chain rule, guys. This is not a proof. If you want a proof, I think you can find the proof elsewhere. Let's get right into it, guys. Alright, so I have, so we know how, well, alright, this is meant for my kids at the moment. We know how to differentiate sine x, and we know how to differentiate x squared minus 4, but how to differentiate a composite function like sine of x squared minus 4? And the answer is, well, we're going to take a derivative by using chain rule. So how does chain rule work? Well, okay, so at the moment, I guess we're not going to explain the chain rule just yet, but I will. Don't worry, guys. Give me a few seconds here, or a couple minutes. So I have a function here, 6x minus 10, and it says that's the same thing as factoring out of 2 and getting 3x minus 5, and it's a composite function of y equals 2u and u equals 3x minus 5. How are the derivatives of all of these three functions related? So they want me to know how the derivative of this guy, how the derivative of this one is related to the derivative of that, and the derivative of this one. So I'm sorry about using this and this and this. It's because they all have just y equals, we didn't say f, g, or h, or anything like that. All right, they're all obviously the same. So here we go. Y prime is equal to, that's just a linear line, that's just 6. Notice that it says y equals 2u. So I'm going to write dy du, so I'm taking the derivative of y with respect to u, and you just get 2. Notice that has a u, so I'm going to write du, I'm taking the derivative of u with respect to x, and I just get 3. So how are they all related? Well, this one looks like, that's just y prime, that's dy dx, right? So maybe I should have said dy dx equals 6. So it looks like dy dx is equal to, it looks like, let's see, it looks like it's equal to dy du times du dx. And sure enough, 3 times 2, that definitely does equal that 6 that I got there. So it works, guys. By the way, this right here is your chain rule. And I'm going to explain it. Don't worry, guys. So here we go. Example 2, it says the polynomial y equals 9x to the 4th plus 6x squared plus 1 equals, and then, yeah, if I write it as a binomial with a square on it, if I expand it, you get this expression. Is a composite function of y equals u squared and u equals 3x squared plus 1. Yeah, I can see that. I agree. Does dy dx equal dy du times du dx? Well, yeah, the du's are going to cancel, so it better. So yeah, let's go ahead. Let's see what, let's find out what this is. So dy dx is going to equal to 9 times 4, that's 36x cubed, plus 6 times 2, that's 12x. So that's what I should be getting. So let's see if we can get that, guys. Dy du. So the derivative of u squared is just 2u. That's it, just 2u, because I took the derivative with respect to u, guys. And then the derivative of u with respect to x is going to be 6x, and you're done. So at first glance, you're thinking, well, it doesn't look like dy dx is equal to this expression, but it is. Notice that u is equal to 3x squared plus 1. So I can rewrite it as 3x squared plus 1 times 6x. And if I want, I can multiply that 6x times 2 there to avoid maybe possible headaches. So you have 12x times 3x squared plus 1. And now I can just distribute like so. 12 times 3, 12, 24, 36. So 36x cubed plus 12x times 1, 12x. And notice, voila, you got the same thing. Cool, right? All right, so let me explain what is happening here, guys. Let me explain why this works. So this, notice that when you take a derivative of a composite function, notice what we did. So we brought this 2 to the front. We left, so look, let's just focus on this. So let's see, I'm gonna write it in blue here, guys. Y equals 3x squared plus 1 squared. So notice what this 2u is. That 2u, so I'm going to write y prime equals, that's bringing that 2 to the front, leaving the inside alone. That's why it says u there. So 3x squared plus 1. And then that 6x came from taking the derivative of the 3x squared. See? So that's exactly what chain rule is. So you take the derivative of the outside, you leave the inside alone, times the derivative of the inside. So when you're saying dy du, that's really just taking the derivative of the outside, leaving the inside alone, because we're doing dy du, not dy dx. So if it was dy dx and there was a u, it would be 2u prime, 2u prime, 2u prime, right? Because if you're doing derivative of u squared with respect to x, dy dx, you would say 2u du dx. Hopefully that made sense. If you haven't done implicit differentiation or related rates, that might not make sense to you, so disregard. All you got to know, right down to it, guys, all you got to know is when you're taking the derivative using chain rule, you're going to take the derivative of the outside, leave the inside alone. In this case, what's considered inside? The 3x squared plus 1. So see, I brought the 2 down, 3x squared plus 1. I subtracted 1 from the exponent. That's why it's now to the power 1. If I would have had a power 3 or a power 4, then we would have subtracted 1 like any regular derivative of a polynomial function, and then times the derivative of the outside. So there it is, guys. I hope we understood that, and let's continue. What we just did is this part. That is chain rule. If you don't recognize that, recognize this. That's chain rule as well. Relax, we're going to explain it. That's what you're taking a derivative of. You're taking a derivative of a composite function. Here's how you say it. So here's my composite function right here in blue. And what you do, you take the derivative of the outside. Notice that g of x is still in there. So you take the derivative of the outside, you leave the inside alone, times the derivative of inside. So let me tell you how it is in words. Derivative of outside, and this is all single quotes, leave inside alone, times derivative of inside. Write that down. Derivative of outside, leave inside alone, times derivative of inside. That's all this means here. That right here is der of outside. The du dx, that's der of inside. If your outside stuff has stuff inside it, leave the inside alone. If the outside one has stuff inside it, leave the inside alone. Don't worry, we're gonna do a whole bunch. So let's see. Let's see how we do it. An object moves along the x-axis of its position at time t greater than or equal to 0 is given by blah. Find the velocity of the object as a function of t. Okay, I just want velocity. I have to use chain rule. The cosine, remember, cosine is never by itself, guys. So the cosine is considered outside. And the t squared plus 1 is considered inside. Cool or not cool? So here we go. The derivative. What's the derivative of cosine? Negative sine. Leave the inside alone. Well, in this case, you have to because it's just an argument, and you always have to leave whatever the inside is of that alone. And then I'm going to go times the derivative of the inside. What's the derivative of t squared plus 1? 2t. There it is. Write it better, maybe. Negative 2t sine t squared plus 1. Sorry, guys, I forgot to bring M&Ms. I really did. Maybe I'll bring some tomorrow. So that's the whole point, like to memorize the chain rule, the M&Ms. Like M&Ms have a peanut and a chocolate and a shell, right? So when I tell you like eat the shell first, so that's like taking the derivative of the outside. You're taking the derivative of the shell, and then you're leaving the inside alone, the chocolate and the peanut. And then you're like, all right, eat the chocolate, but leave the peanut alone. Like that's like a 3-ring chain rule. You know what I mean? All right, so look, here it is. Here it is. It is sometimes hard to think about the chain rule this way. If y equals f of g of x, a composite rule, the derivative is the derivative of the outside, leave the inside alone, times the derivative of the inside. And look, I even put it in words. I didn't even know how to put that in there because these are from last year's notes. I didn't edit them. In words, differentiate the outside function f and evaluate it at the inside function g of x left alone. Then multiply by the derivative of the inside function. So you'll hear me say, take the derivative of the outside, leave the inside alone, then take the derivative of the inside. Yeah, we're gonna solve a whole bunch. Oh no, you don't need a song. Okay, here's the song. Derivative of the outside, leave the inside alone. Then take the derivative of the inside. Oh, I like that song. I'll stop. If I ever own a church, I'm gonna buy so many pyrotechnics. It's gonna be the best church ever. Yeah, you heard me. Hallelujah. Okay, example 4. Differentiate sine of x squared plus x with respect to x. Here we go. Chain rule. I don't have an x by itself. If I just had an x by itself, I would just say the derivative of sine x is just cosine x. Sine of x squared plus x. So here we go. Here's how you say d dx. I'm taking the derivative of sine of x squared plus x. So I'm going to take the derivative of the outside. The only thing on the outside is sine. So the derivative of sine is cosine. So I write cosine, leave the inside alone, times the derivative of the inside. What's the derivative of x squared plus x? There you go. There's my answer. Done. If you don't put parentheses, it will be counted wrong because it's not cosine times 2x and whatever that is plus 1. It's a product of cosine of x squared plus x times 2x plus 1. And you're done. That's it. Look at this one. This one's a triple link chain because there's several insides. So this one has, look, there's a 2t in front of that sign in there. So you have an inside with an inside, like an M&M. So you always work your way outside towards the end. So g prime of t, here we go, is the derivative of the outside. What's the derivative of secant? Oh, damn it. Darn it. Sorry. What's the derivative of tan? Sorry, guys. I didn't mean to say that. Now I feel like I'm not going to heaven. I'm going to heaven, guys. I'm going to have to pray in a little bit. You leave all of the inside alone. I'm just thinking of when am I going to pray. I'm going to pray as soon as you guys are out. Times the derivative of the inside. What's the derivative of 5? 0. Don't look at that then. What's the derivative of sine? Well, the derivative of cosine is negative. So this one stays as negative. I'm going to write cosine of 2t. But then that has an inside as well. Times, what's the derivative of 2t? 2. There it is. I did my triple chain. Rewriting it, an M&M has the shell, chocolate, peanut, and you work your way from outside in. If we had M&Ms, I would say, here, eat the shell only. And you guys would have eaten the shell, leave the chocolate alone. All right, now eat the chocolate. Then you would have eaten the chocolate, leave the peanut alone. Like, all right, now eat the peanut. So it's exactly like an M&M because we're working outside in. But I didn't bring in M&Ms, but yeah, it's like an M&M. 2 negative 2 secant squared 5 minus sine of 2t close cosine of 2t. Done. Class, virtual class, is this getting easier?
Yeah.
Okay. All right, no, look, don't worry. It's gonna get, you're gonna understand everything perfectly right now with this example. With this one, example 6? Oh, no, you don't. You don't have to rewrite it. If this were an AP question, you could leave it alone right there. But if it's a multiple choice, they probably would not leave it like that. You probably have to recognize that the negative there goes to the front. You know what I mean? All right, look at this question, guys. So here comes a little bit of pre-cal. No calculator. You can do this without a calculator. It says find the slope of the line tangent to the curve. Oh, it's even easier. They don't even want the tangent line. They just want the slope. So what do I do to find a slope? Take a what? Before you do that, you're right, derivative. Rewrite it. That sine to the fifth power x is the same thing as this. So now look what's on the inside and look what's on the outside. The sine x is on the inside. Does that make sense to everyone? So here we go. 1 to the power, 1, an expression to the power 5. So here we go. Derivative. What do I do with the 5? Bring it down. Leave the inside alone. Sine x, close it to what power? Fourth. Am I done? No, times the derivative of the, what's the derivative of sine x? Cosine x. If you understood that, you understand the chain rule. Derivative of the outside, leave the inside alone, times derivative of the inside. Next, I'm going to plug in a power over 3 because that's what I want to know. 5 sine of power over 3, and maybe I didn't have to do this because I think you guys are smart enough to know. What is sine of power over 3? Is it a half? Is it square root of 3 over 2? Pi over 3 is at 60 degrees. The x is a half. The y is square root of 3 over 2. Is sine x or y? Y. Here comes your pre-cal, guys. It's not even extreme pre-cal. It's just basic pre-cal. And then this one is going to be a half. Can we do this without a calculator? Yes, you can. Si se puede. Lo pueden hacer. Why'd I put what? Oh, you're right. I don't know. I was just being silly. I wanted to throw a curveball. No, I just put it white prime prime for whatever reason. Square root of 3 times square root of 3 times square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3, 9. Yeah, square root of 3 times square root of 3 is 3, and then square root of 3 times square root of 3 is another 3, so it must be 9. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16. Finally, 5 times 9. Is that 45? 16 times 2. There it is. 45 over 32 is my slope when x is pi over 3. For the function sine to the fifth power of x. If I say u equals sine x, this is like saying y equals u to the fifth. So the outside is, I guess, 1, some variable to the power 5, and u is the inside. Yeah. Yeah, whatever's on the inside has to have the variable x. If not, we can't do chain rule, right? If it just had like 3 to the power, or 3 times pi to the power 5, please don't tell me that's 15 pi to the power 4. Pi is a constant, right? You know what? I'm going to put that as a test question. What's the derivative of pi to the power 5? You better not tell me 4 pi to the 4th. No. It's not 5 pi to the 4th either. It's a constant, guys. Pi is a constant. It's not a variable. It's not x. It's not changing with respect to anything. It's just a constant. It's just a number. It's 0. The only thing that is changing with respect to whatever, it's some letter, some variable, guys. That's all we've been doing. Limits. That's the whole point. If I tell you find the rate of change of pi with respect to x, you're going to tell me 0 because there is no x on pi. It's not changing. It's always pi. Sorry, I got hyped there. That was not angry hype. That was like I want to make sure you get it hype. Okay, pi is a constant. You cannot do that. That you will win the Nobel Prize if you do that. You can't take a derivative with respect to a constant, like, oh, take the derivative of pi with respect to a pi. No, that's, no. The mathematician would look at you and be like, what are you on? What drugs are you taking? No, no, in a nice way. I hope I'm not being savage. I'll stop. All right, here we go. Example 7. Do not do quotient rule on this one. You don't need to do quotient rule on this one. What did I tell you last time, Ms. Godinez? Bring it up. So this is the same thing as saying, rewrite it. d dx, parenthesis, 1 minus 2x to the power negative 3 close. Bring it up. If you have a constant on the top, bring it up. And now look, you can do chain rule really fast. What do you have on the inside? What is the inside? 1 minus 2x is the inside. So in case you're wondering, Chavez, I don't understand what you mean. Chavez, I don't get what you mean, Chavez. That's you guys. This is like that, where u is 1 minus 2x. Here we go. Derivative of the outside. The negative 3 is on the outside, so what do I do to that? Bring it to the front. Perfect. Move it over. So negative 3. Do I leave the inside alone? Yes. Heck yeah, you do. 1 minus 2x to the power, what power? Negative 4. Am I done? Times what? Times negative 2. Let's fix it. They probably want it with positive exponents. Negative 3 times a negative 2 is a positive 6 over 1 minus 2x to the 4th power. Do you feel, you guys feel okay? No, you're not going to forget, because you're going to be doing this all of calculus. All of calculus. You're not going to forget. In case you want to see a proof, because a lot of you are probably like saying, Chavez, I'm doing this sequence and I kind of feel a little robotic right now, and you always tell me not to be a robot. So can I see a proof of this? Come by after school and we can do a proof of this, or go to Khan Academy and put proof of chain rule, or YouTube put proof of chain rule. It's okay. I don't want you to be a robot, but understand that all we're doing is taking a derivative of a composite function. So remember that all these derivatives comes from something. They come from patterns. They all come from the limit notation. Limit of f of x plus h minus f of x all over h. All of them come from that. So yes, all we're doing is a rule. That's all we're doing. So if you feel a little robotic, that's okay, because all we're doing is applying a rule. It's like applying a definition. So if you feel a little robotic on this section, it's okay. You're not a robot. You're just applying a rule, that's why. Are we okay? Okay. Let's go to this one. And let's see how good you guys are. This is from page 162 of your textbook, but joke's on me. No one has a textbook, ha 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 ha. Take 2 minutes, see if you can figure this question out, and then send me a DM with your answer choice, and we'll do it in a little bit together at 10:30. So take 2 minutes, guys. You got an answer? All right, here we go, guys. You guys got an answer? All right, dy dx, y prime, or dy dx, it doesn't matter. What's the derivative of 10? Secant squared of 4x. Am I done? Times what? Times 4. 4 secant squared 4x. All right. Did they want the second derivative? No, just first dy dx. That's weird. That was a simple one. Okay, I guess. All right, take another 2 minutes. See if you can do question 2. Should I start it? All right, guys, I'm gonna go ahead and start it. First thing you guys gotta do, you gotta rewrite it. Unless you already see it, but I would rewrite it. Cosine x cubed plus x squared, all of that is raised to the power. Did you get it like that first of all? Okay, so you gotta make it like look like this. Unless you see it, like once you're a professional, you've been doing this for a while, you'll see it automatically. So by the second semester, you'll see it and you'll just write the 2 in the front. Well, I haven't taken the derivative yet, right? You probably already went right to it. Y prime. Bring the 2 to the front. Leave the inside alone. And for now that we're rookies, maybe we should rewrite it like this. To the power 1, we don't need a power 1 because, anything to the power 1 is itself. Am I done? No. Times the derivative of the inside. What's the derivative of cosine? Negative sine, x cubed plus x squared. Am I done? No. One more derivative. The inside of that. What's the derivative of that? Perfect. Rewrite it. Yeah, M&M. You're working your way outside in. Well, the whole thing is called the derivative. Oh, no, S. It's all good. I want to understand this. There it is, guys. There actually is a property that we could use, and if they wanted to be really mean, they could change the answer choice. But no, it's in there. Which one is it? Yeah, it's letter C. They could, if they wanted to, have changed it up, by the way. If they wanted to, using a property of double angles, because I see cosine sine, and you guys know your cosine, remember like cosine A plus B and all that? They could have, because look, I see a 2 in there, and I see cosine sine. So they could have changed it if they wanted to, but they didn't. And for now, they probably didn't change it because we're rookies. Okay. Well, I thought we were going to take longer, but I guess we're getting through it pretty quickly. You guys ready for this? Let's see if we can at least get to letter F. Okay, let's go ahead and start. It says, suppose that the function f and g and their derivatives have the following values at 2 and 3. Evaluate the derivative with respect to x of the following combinations at the given value of x. So they want the derivative of 2f of x at x equals 2. So that derivative is 2f prime of x. Nothing fancy there. So then at 2, it just becomes 2f prime of 2. 2 times f prime of 2, 2/3. Is everyone okay with that one? Yeah, Con? Okay. They want the derivative of f of x plus g of x at x equals 3. The derivative of that is just f prime of x plus g prime of x. So nothing fancy there again. At x equals 3, so go to 3. F prime is 2 pi. So f, well, I guess let me write it. So f prime of 3 plus g prime of 3 is equal to, f prime of 3 is equal to 2 pi plus g prime of 3 is equal to 5. 2 pi plus 5. 2 pi plus 5, because the pi kind of sounds like a 5. This is the AP score we want for everyone, a 5. We'll have lots of pies at the calculus social. Letter C, and Ms. McLaren will personally give you guys a handshake and tell you congratulations. She's like the president of the United States, so. Huh? Oh, you're saying she's not going to give handshakes because of the pandemic? Oh, well, by that time, there won't be a pandemic. Okay. Godina's just looked at me and judged me, guys. She gave me that look. This was you. But don't worry, we're all friendly here. We all love each other. This was her. She looked at me. I said, like, there's not going to be a pandemic. And she's just like this. She's like, slowly judging me. We're good, miss. I'm giving you a hard time. All right. What rule do I got to use on this one? Yeah. first f of x times root of the second plus second times root of the first. Now I'm just going to plug in. So I got to put the word so in there because now I'm evaluating it at 3. F of 3, g prime of 3 plus g of 3, f prime of 3. And then I'm going to minimize this so I can see what my table is, guys. F of 3 is 3. G prime of 3 is 5. G of 3 is -4. F prime of 3 is 2 pi. So let's see, 15 minus 8 pi. What rule do I got to use for this one? I'm going to change the color so I can fit it all in here. Yeah, quotient rule. Bottom times root of the top, low d high, minus top times root of the bottom, high d low, all over low low. It sounds like if you're playing like that, what is it called when you're going under the stick? I don't know what that's called. Whatever that's called. Oh, I caught it, guys. I caught a mosquito, in case you're wondering. All right. Here we go. What? G of 2, f prime of 2, minus f of 2, g prime of 2, all over g of 2 squared. And I don't know if I'm going to have enough room, guys. I'm going to try. G of 2 is 2. So 2 times f prime of 2, which was 1/3, minus f of 2, which is 8. And then g prime of 2 is -3, all over g of 2, which is 2 squared. That's some number. I'm not going to simplify it. I'm going to leave it like that. Because I just can't fit it. I probably could if I really tried. Is it okay if I leave it like that? Okay. All right, letter E. D dx of f of g of x. What rule is this one? Chain. There's just plain old chain rule. Get rid of the outside, leave the inside alone, times get rid of the inside. There it is. So f prime of g of 2 times g prime of 2, which equals f prime, g of 2 is, g of 2 is 2. So it comes out to f prime of 2, g prime of 2 by coincidence. So f prime of 2 is 1/3. And then g prime of 2 is -3. So it comes out to -1. All right, I'm going to try to write small on this one. I'm going to rewrite it, guys. Oh, should I slow down? Okay. Why are there so many mosquitoes around here, guys? You guys haven't gotten bitten? Man, I feel like I got bit right here. Okay, d dx. This is the same thing as f of x to the half. What rule am I going to use? Chain. Bring the half to the front, leave the inside alone, right to the negative half on the outside, because I subtracted 1, times the derivative of the inside, f prime of x. If you want to rewrite it, here's how it looks. F prime of x on the top, in the bottom, put a 2 square root of f of x. Now we're ready. So f prime of 2 over 2 square root of f of 2 f prime of 2 is, f prime of 2 is 1/3 over 2 times the square root of f of 2, which is 8. And I think we have enough room. Let's see, 1/3 over 2, 4 times 2, so times 2 square root of 2. So 1/3 over 4 square root of 2, 1 over 12 square root of 2, and times square root of 2 over square root of 2. I'm going to put it right up here, guys. I'm sorry. 1 square root of 2, square root of 2, 12 times 2 is 24. There we go. Square root of 2 over 24. All right, can we take some more, guys? No? Well, if we don't have the energy, we got 2 left, but you need your ultimate energy for the last one. Okay. All right. Godinez said that she gave you guys energy. What? Oh, yeah. I'm gonna go slow. All right. So I want the derivative. No, I'm gonna go slow for else. I know you're thinking like he's never gonna go. Like, no, I am. So I'm gonna rewrite this, guys, as g of x to the -2, like so. See? That's all it means. It means that g is being squared. So it means g of x, a function g of x is being squared. So I'm going to do chain rule, bring the -2 to the front, leave the inside alone, to the power -3 times the derivative of the inside. If you rewrite this, I got a lot of white space now, so now I can rewrite all I want. So I'm going to have -2 g prime of x over g of x, and all this is raised to the 3rd power. Are we okay so far? Tiff, are we okay? Yeah, Kana, are we okay? You've been pretty quiet since Nam. Since Vietnam? Since Vietnam? I'm sorry, miss. It was a joke, but it wasn't very funny. I apologize. But you're okay though, right? Yeah. Okay, so are you okay with up to this point? All right, so now what I'm gonna do is I'm gonna plug in a 3, guys. So I'm gonna have -2 g prime of 3 over g of 3 squared. Can someone do me a favor and tell me what g prime of 3 is? 5? And what's g of 3? Negative what? 4 squared. Okay, so I have, no, it's over, oh yeah, to the 3rd power. I know, man, I make mistakes. Sorry. All right. So now I have a negative divided by a negative, which is going to be positive. 2 times 5 is 10. And then 4 to the 3rd power. 4 times 4 is 16. 16 times 4 is 32, 64. That reduces, let's see, 5 over 32. I think that's it. Remember what I told you anytime there's a constant on the top? Every time there's a constant, what do? You could have done quotient rule. It would have been nastier though. No, once you take the derivative, that's it. That is your derivative. Don't be doing anything else to it. You know what I mean? All right, letter H, try to write small because we're probably gonna take up all this room here. First thing, I'm gonna rewrite it. I'm gonna rewrite it like this. ddx, giant parenthesis of f of x squared plus g of x squared, close that giant parenthesis, In case you can't see it, it's this one in blue. Squared. Oh, no, not squared. To the half. Before I continue, is everyone okay with that expression? All right. I'm about to take the derivative, guys. So it's going to get ugly. So here we go. I'm going to put the equal sign, meaning that I'm taking the derivative. It says d dx. Bring the half to the front. Leave the inside alone. So I'm going to do that with blue here so no one gets confused. So here's my inside left alone. I'm going to subtract 1 from the half. So that is a negative half. And now I'm doing the derivative of the inside. So notice I have f of x to the power 2. So that's going to be 2 f of x times the derivative of the inside, f prime of x. Are we okay there? Okay, don't worry, that's not the only part. I still have some more. This in green, if I told you to take the derivative of that, you have to do chain rule. 2 to the front, leave the inside, f of x, times the derivative of that inside. I'll put it here on the side. d dx of f of x squared is 2 f of x times f prime of x. Do we see it now, Godinez? Yeah, the chain rule. Outside 2, bring it to the front, leave the inside alone, f of x, times the derivative of f prime, the inside. Okay. Plus 2 g of x times the derivative of the inside, g prime of x. And this really is another parenthesis right there together. I'm going to rewrite it. Here's how it looks. This here is in the top. So I'm going to rewrite it as 2 f of x, f prime of x. If you want to put parentheses, go for it. Plus 2 g of x, g prime of x. All over, and I'm bringing the f of x squared plus g of x squared down, and I have a 2 in the bottom, square root of f of x squared plus g of x squared. What can I cancel, or what can I factor out? I can factor out a what? A 2. So factor out the 2's, and you factor out the 2's all go away. Maybe it makes it simpler, maybe not. So, I guess I should go back to, so, what do they want it at? X equals 2? So then I should have f of 2, f prime of 2 plus g of 2, g prime of 2 over square root of f of 2 squared plus g of 2 squared. Someone hook me up with those numbers. What's f of 2? 8. What's f prime of 2? 1/3 plus, what's g of 2? What's g prime of 2? All over, what's f of 2 again? Was it 8? And then you said 2 squared for g of 2? It's that, whatever that is. Should we try to figure it out? Probably, right? All right, let's try to figure it out. 8/3 minus 6. We'll figure that out in a little bit. 8 squared is 64. 2 squared is 4. So square root of 68. Square root of 68. That breaks down to 4 times 17. So I'm gonna have, let's see, let's do the common denominator here, 6 times 3. So 8/3 minus 6, 12, 18. 18 over 3 over 2 square root of 17. 18 minus 8 minus 18, that's a negative 10 over 3 over 2 square root of 17. So negative 10 over 6 square root of 17. Don't worry, we're almost done, guys. Negative 10 square root of 17 over 6 times 17 over 102. And then finally, oh yeah, negative 5 square root of 17 over 51. What do you guys think? If this were a real question on the AP exam, which I guess it could be, free response, you can stop right here. Do you have to solve it? No, as long as all the numbers are in there. I mean, who knows? Maybe I messed up. There's a chance. You never know.